you about a friend of mine named of Dan Larson. He lives in a small town not too far from here. Dan's in the service department of a dealership there. A couple of weeks ago, I stopped by and found him working on a transmission from a local taxi cab. First thing he said to me was,
"Just look at how these low and reverse sliding gear teeth are chipped and broken, Tech. And to think that a few simple adjustments made in time would have prevented all this trouble. But no, this guy let it go until it got really serious. And he should know better, too."
"Well, that's too bad, Dan. Who is the owner?"
Oh, his name's Gus Heinrich. He and his partner own a small fleet of cabs here in town. Gus does a lot of the routine service on them himself, but we still get the rest of his service work. He let this go too long, though. Probably felt that those hard shifting gripes weren't too important at first. But when it got noisy, he finally brought the cab into us. Just look at the way these low and reverse sliding gear teeth are chipped on one side. Well, you can tell it was running only partly engaged.
Yeah, and like you said, Dan, a simple adjustment of the gear shift linkage at the right time could have saved all this trouble.
Exactly, Tech. But instead, I've got a transmission to overhaul now. So how about staying around and giving me a few tips?
Okay, I'll be glad to. First of all, I hope you checked the end play of the countershaft cluster gear before you removed it.
Oh, sure, I always do, Tech. On this job, the cluster gear needs new thrust washers. I also checked the end play of the second speed gear to see if I needed a thicker clutch gear snap ring. And sure enough, I did.
Here's something to watch for. If there's any trace of a leak out past the front of the countershaft, right here, remember to coat this bore with gasket sealer during reassembly just before you finish driving the shaft into place. Apply a thin coat of gasket sealer all the way around the bore to seal the shaft completely. Don't get any inside the transmission case or on the front surface, though.
That's a good point, Tech. Now, this low and reverse sliding gear can't be saved, so I'm going to put in a new one. Any tips on gear replacement, Tech?
I sure have. Always look over the mating gears to make certain they are all right. Minor nicks can sometimes be stoned out to save a gear. Whatever you do, don't replace gears or other parts that are okay for service. Needless parts replacement is a good way to drive customers away. Another thing, make sure you use the right replacement gears. The number of teeth varies on different applications. If in doubt, count the gear teeth to make sure you're right.
I'll pass that tip on to our parts department, Tech. I'm sure they'd... Hey, here comes Gus Heinrich, the fellow who owns his cab. Wonder what he wants.
Hi, Dan. Thought I'd drop in and cool off a bit. How's my transmission coming?
Oh, you're just in time, Gus. My friend Tech and I were talking about it when you walked in. One of your gears was pretty badly chipped, so I'll replace it. If you can wait till I get your transmission back in, I'll show you how we adjust the shift linkage so this won't happen again.
Fine. I'd like a good excuse to stay out of that sun.
Before you install that countershaft, Dan, are you sure you used the right thrust washers?
You bet. And I followed the service manual literally word by word to be sure they're properly installed. The end play is within limits, too.
Looks to me like you could install that reverse idler gear either way on its shaft.
Well, it's possible, Gus, but the right way is with the beveled ends of the gear teeth forward, like this. And by the way, did any of your drivers complain of hard shifting coming out of neutral to another gear with this cab?
No, they haven't, Dan. Why?
Well, sharp corners here on the neutral detent notches in the two shift lever cams sometimes cause this trouble. When that happens, I stone down the sharp edges slightly to match the rounded edges of the other notches before I install the shift lever shafts.
Say, Dan, are these shaft seals in far enough?
Oh, they sure are. This seal driver tool installs them flush with the surface. Any deeper, they won't seal properly.
And don't forget, Dan, that those retainer pins have to be driven in just the right amount, too. Firmly, yet not enough to bend the pin or mushroom it.
That's a good tip. And here's another. Always test for a free sliding fit of the low and reverse sliding gear along the full length of the main shaft splines. If there's any binding at all, turn the gear to match up the splines differently, and then test it again.
If the gear still binds, try polishing down the major diameter of the main shaft splines with fine abrasive cloth. If that doesn't work, Try a different low and reverse sliding gear.
Hey, Dan, are you going to put in all those snap rings?
Oh, no, Gus, just the right one. You see, these snap rings for the synchronizer clutch gear come in different thicknesses. So I'm selecting the thickest snap ring that'll fit in order to eliminate all the synchronizer clutch gear end play. That, in turn, minimizes second speed gear end play.
Too much end play would cause second speed gear jump out and damage to the synchronizer assembly.
Selecting a drive pinion retainer gasket of the right thickness is important, too. If you use a gasket that's too thick, you won't eliminate all the bearing end play. And a gasket that's too thin could cause a lubricant leak.
You'll find the full story on all these select fits and a lot of other overhaul pointers in your service manual. Keep it handy and refer to it often.
Well, Gus, your transmission's ready. But before I install it, I want to make sure that it's going to line up properly with the center line of the crankshaft.
If the clutch housing doesn't line up properly, the car will be back in for service before long.
That's right, Tech. I always check the runout of the clutch housing bore and face on every transmission overhaul.
Excessive bore runout should be corrected by installing a pair of offset housing alignment dowels. Excessive face runout should be corrected by shimming.
Hey, that's automatic transmission fluid you're using.
Don't worry, Gus. That's what they're using now at the factory. And it's recommended for service, too. It has some advantages like easier initial shifting in cold weather and longer gasket and seal life.
Shouldn't you grease the splines, Dan?
Oh, definitely not. The less lube near the clutch, the better. The only spot to lubricate is the inner end of the drive pinion pilot bushing in the crankshaft. And use only a little lubricant because any excess will leak onto the clutch and cause trouble. Now I'll install this transmission in your cab. Okay, Gus, everything's set. I'll show you how to make those adjustments after I get a drink of cool water.
I could use one, too. How about you, Tech?
Be right with you, soon as someone turns this record over to the other side.
That's better. Now I'll adjust your gear shift linkage, Gus. You know, this taxi has the heavy-duty linkage to go with its heavy-duty transmission. You can identify the heavy-duty linkage by this interlock pin down here at the lower end of the shift tube. It also has a heavier low and reverse rod. The adjustment for the standard and the heavy-duty linkages are quite similar, but where they're different, I'll cover them both so you can keep your own car adjusted right, too. If the linkage is out of adjustment, you might get hard shifting and chipped or broken gears, so you can see how important these adjustments are. Begin by checking to see if you've got about 5/8 of an inch clearance between the bracket for the shift levers and the arm on the clutch torque shaft when the clutch pedal's fully depressed. Also be sure the steering column jacket is centered around the steering tube. If you have to adjust either of these items, loosen the clamp bolt and these 4 stud nuts. Then, if necessary, turn the clamp to set the clearance between the bracket and the arm on the torque shaft. As you tighten the clamp bolt and stud nuts, hold the steering column jacket centered on the tube. Tighten the clamp bolt to 200 inch-pounds and tighten the 4 stud nuts to 85 inch-pounds.
When you tighten the clamp bolt, be careful not to over-torque it, or the clamp will take a set which will prevent any further adjustments.
Remove the lube fitting and turn the crossover pin retainer so you can see the head of the crossover pin. This heavy-duty linkage has a round-headed pin.
The standard linkage has a pin with a square head. Be sure you've got the right pin installed.
Also, make sure that the slots in the hubs aren't worn excessively. Then turn the retainer back and install the lube fitting. Next, put the gear shift lever in low gear and notice how much free play there is at the lever. Then do the same in second gear. The free play in both positions should be equal. There's normally about 1/8 to 1/4 of an inch of travel at the knob. If there's too little free play in either position, slightly loosen the clamp bolt and the lower 2 stud nuts and tap the clamp up or down to get equal free play at the lever. Then tighten the clamp bolt and stud nuts to the correct torque.
Use a soft-faced hammer and take it easy. Remember, you'll need to move the clamp only a few thousandths of an inch to equalize the free play.
On this heavy-duty linkage, the interlock pin determines the neutral position of the gear shift lever. Be sure and check the adjustment of the low and reverse swivel to make certain the interlock pin is centered when the transmission's in neutral. To do this, wiggle the low and reverse shift lever both ways as far as it'll move with the interlock pin engaged to determine its backlash travel. The shift lever should be held exactly in its mid-backlash point by the neutral detent in the transmission. If you have to adjust this setting, just loosen the swivel on the low and reverse control rod and retighten it while you hold the shift lever at its mid-backlash point. Finally, set the parking brake and idle the engine. Try to shift into low and reverse with the interlock engaged by moving the control rod. If the gears clash when you move the rod in either direction, shut off the engine and readjust the low and reverse swivel to eliminate the clash. Now, with the standard linkage, the gear shift lever should normally be horizontal when it's in neutral. Make any adjustments at the low and reverse control rod swivel only. We'll talk about adjusting the other swivel in a minute.
Of course, you can change the neutral position of the gear shift lever in the standard linkage to give your customer more knee room in high gear or greater clearance from the heater push buttons in second.
Here's a good way to test the crossover adjustment. Move the gear shift lever through the neutral crossover several times in each direction while holding a slight downward pressure on the lever. Then repeat this test with a slight upward pressure on the lever.
If there's any lumpiness in the crossover, you'll feel it.
Eliminate any lumpy crossover feel by adjusting the swivel on the second and high control rod only. Don't change the setting of the low and reverse control rod swivel.
Some swivels are fastened to the control rod with 2 lock nuts, while others have a clamp and clamp screw. Tighten the lock nuts to 70 inch-pounds. Tighten the clamp screws to 100 inch-pounds. Make sure a hard shift won't change the crossover adjustment.
Do this by jamming the gear shift lever into reverse hard. Then check for any change in crossover feel. After that, make the same test in low, second, and high. If a hard shift into any gear changes the crossover feel, you'll have to find out why it changed and correct the condition.
You'll find some good tips on what to look for in the reference book.
As a final check for linkage interference, shift into each gear with the engine off. Floorboard the accelerator and depress the clutch on each shift. Any interference or binding should be corrected. Well, that's it, Gus.
Thanks a lot, Dan. You've sold me on the importance of correct linkage adjustment.
Well, there's one more adjustment related to transmission operation that should be checked periodically, so let's review it now. I'm talking about the clutch pedal free play adjustment. There should be 5/32 of an inch of free movement at the outer end of the clutch release fork.
I usually check this adjustment by measuring the free travel of the pedal itself. Isn't that okay?
Oh, no, sir. It's too unreliable. Measuring the actual movement of the clutch release fork itself is much more accurate. Okay, Gus, your cab's ready to go.
Thanks, Dan. And thanks for the tips on linkage adjustment, too. You know, that's what I like about this shop. Not only do you have the training, the equipment, and the parts, but most important of all, you've got an honest desire to see to it that all your products are serviced right. But maybe you'll let me say thanks in another way. How would you two fellas like to come out to my cottage for a swim this evening? Then we could go out.
Well, that's the story. It proves it's always possible to learn something new about an old friend. The manual transmission in this case, and, like Gus said, you master technicians have the training, the equipment, the proper parts, and I'm sure a desire to do a good job of servicing Chrysler Corporation cars. This all adds up to satisfied customers, and they make a successful dealership.